Hey gang, it's John Lockwood here with CodeSolid. I wanted to do a quick video on Python virtual environments. And this slide is not going to be really long. I'm going to gloss over it real quick, but we're going to dive right into the commands. I know that's what you probably want to see. So first thing I'm going to show you is how to create and use virtual environments. And once we've done that, we want to dive in a little more into what the commands mean. The third thing, and this is even more along the lines of good context to have, is why even bother, right? I mean, why even bother to learn this? There is a good reason for you using Python virtual environments, but newcomers often don't learn how to do it right off the bat, and then they get into trouble later when they find that they have version conflicts or package conflicts. Finally, we want to get into a few other tips that will help you use virtual environments effectively. And with that, let me get to a command prompt and we'll dive right in. So here we have a Mac terminal prompt. And our first thing we want to do is we want to check and make sure we have a fairly recent version of Python and pip. So let's do that. Let's do Python -- version. And we have 3.11.2. Everything I'm going to show you will actually work if you have Python 3.4 or greater. If you're not seeing, if this is showing a version earlier than that, especially if it's showing Python version 2, you might try typing Python 3 version. Let's also check pip and make sure that's okay. Yeah, sure enough, that's pointing to Python 3.11, and it's a fairly recent version of pip. So everything will work. And again, if pip didn't work, you could try pip 3. Now that we know we have a decent environment, we're going to create a project. Virtual environments are very much tied to Python projects. So the idea is that each project will have its own, and that way we can avoid conflicts. So let's go ahead and create a project with a really creative name. I'm going to call it Project 1. Oh my goodness, I can't believe just the quality sometimes of these names I come up with. Let's go into Project 1, and at this point there won't be any files here. So creating a virtual environment, that's our first step. Generally, you create a virtual environment once and you activate it many times for any given project. You can activate it and deactivate it. So here's the command to create it. And this command, by the way, is the same on Mac, Linux, and Windows. So that makes it nice. Once you've learned it once, you can basically use it everywhere. As you can see, this is a little bit confusing. I'm going to break this down for you later on when we talk about what these commands mean. But for now, just take it as gospel that this will do the right thing. The command is Python -m venv and then venv once again. Sometimes you'll see people use .venv here, but I like to keep it not hidden in case I want to explore the files that are in it. That second one actually relates to the directory name. So we go ahead and type that command, and you can see it took a second. And then what happened is we ended up with a directory on our machine here, which is why virtual environments tend to be specific with the project, to the project that they relate to. So now that we have a virtual environment, let's do the command to activate it. And the command for that is actually different on Mac and Linux is one way of doing it, and then there's a different command that you use on Windows, and I will show you that in a minute. But first, here's the command that will work on both Mac and on Linux. We want to do source, and source is a way of saying basically run the shell commands in the current environment, rather than running like a bash script or a ZHS script. We say source, and then we're going to say venv, and then bin, and then activate. And I want you to pay attention to what happens to the command prompt when we do this. You can see right now we're looking at a command prompt that looks like Project 1, right? So now we do activate, and what happens? You can see at the beginning, we now have in parentheses venv, which is telling us that we have activated a virtual environment. At this point, we can go ahead and use the virtual environment. But before we do that, let me take a minute and show you the same command on Windows, because this is a little bit different if you're working on Windows. So on Windows, as you can see, I cheated a little bit here, and I have screenshots for you. I prepared these earlier. On Windows, the command that we want to use is right here. It's venv scripts, capital S, although depending on whether you're in PowerShell or not, that may or may not matter. And then activate.bat. So you're actually running a batch file. So it's venv backslash scripts backslash activate.bat. And you can see, just like on Linux, what happened is that the prompt changed after we ran this command. The other thing, if you're using PowerShell, that you may see, if you don't actually use activate.bat, you just type activate and you're in PowerShell. At this point, you're actually running a PowerShell script. And then you'll get this warning that says, do you trust this? And I do, because I know that this was running a Python module, and I trust Python to install something reasonable. So I just told it to run all of the time. So again, it's venv scripts activate or activate.bat on Windows. Activate is the only command that we have to worry about. That is the only command really that's different on Windows and Mac. Everything else that we're going to do is going to be the same in all our environments, which is very nice. And let's try now installing something. And what we've done behind the scenes here is that we now have a version of Python and a version of pip that are separated from the rest of the system. And we can show this if we want. If we were to do which Python now, you can see that this returns the directory that we're in and the virtual environment underneath it, and there's a copy of Python in there. And we can do the same thing for pip, which pip, and you can see that we're now using this version. So if we were to install something now, let's say we want to install NumPy. We want to do some numerical stuff. We want to deal with, let's actually type pip install NumPy. We want to maybe work with some arrays. By the way, you may get this warning about pip install upgrade pip. If you're automating these commands, you may want to add that as one of the things you do. We're just going to work with the old version for now, since we don't need to upgrade it for our purposes here. Okay, I've gone ahead and cleared the screen. At this point, we can run Python if we want, just to verify that NumPy was successfully installed. If I do import NumPy at this point, we'll do it as we would in a Jupyter Notebook, for example. Import NumPy as NP. We can now do NP, let's say a range 1 through 11. That should give us the numbers from 1 to 10 as a NumPy array. Sure enough, there you go. All good. If we exit out of there, our final step, now we could enter Visual Studio, we could enter different IDEs at this point. Different IDEs behave differently as far as this goes, but we'll show a little bit of that later. But I wanted to show you how to deactivate things. To deactivate, we simply type deactivate. And behind the scenes, what's going on is that there is, in the bin directory, there's an executable called deactivate, which will get us back to our original state. And at this point, we can verify. Let's go ahead and run Python again, and let's try importing NumPy. And now you can see we get a module not found error, because as we predicted, what we did in the virtual environment didn't affect the outer system, which is exactly what we want. We don't want a bunch of things cluttering up our global Python environment. So let's go ahead and exit again. Okay, at this point, what I'd like to do is review these commands really briefly, and I will include a link to a website where all of this will be copy and pastable. I'll also include the slides over there as well, if you want to review those. But basically, what we did, just to go over it real quick and explain it a little more, our first thing is we created the environment. And actually, that first venv in this command, the one that comes right after the -m, there we're running a Python module, right? So there's a Python module called venv, which creates virtual environments. That second argument, that second venv, the one at the end, is actually an argument to the venv module. And that's why that second argument is really just done by convention. It doesn't have to be venv. If you wanted, you could call your virtual environment Charlie. It really doesn't matter what the name is. It is good to use the conventions that other developers are going to use, just to get used to them. The second step, we activated it. And this was the one step, once again, where it's different between Windows and Mac or Linux. Again, on Windows, we're running a batch file. So we're doing VM scripts activate, for example. On Mac or Linux, we have to type source to bring the commands into our environment, and then it's VM bin activate. So it's actually a different path as well. Finally, once you've done that, once you've created the environment and activated it, you're ready to use it. So you can do pip install pandas, you can do Python, you can do whatever you like. And then the last step, when you're done with the virtual environment, and this step really is optional unless you're going to do something else with that terminal, is that you want to deactivate it. The next thing we want to dig into a little bit, and I promise this would be more of the background and more of the motivation for why you might want to practice this a little bit when you're done with the video, is we want to understand, well, why bother? Why don't we just go into Python and start, whenever we need a package, we need pandas, we install pandas, we need the request library, we install that. We need NumPy, whatever, JupyterLab, you name it. There's some third-party packages, pip install, and we just throw everything in the global environment. Well, why not? Well, let's say, for example, that we have two projects. And again, I'm going to use my real creative naming conventions here. Let's say we have a project 1 and we have a project 2. So project 1 depends on package A. Project 2 depends on package B. That seems relatively harmless, right? Well, what about this case? Let's say that project 1 depends on package A, and package A depends on package C. So there's what we call a transitive dependency. Package A can also have dependencies. So it has package C, and it says, I want version 1.0 of that. Project 2, on the other hand, depends on package B, a different package, and that one also depends on package C. So we have package C as a transitive dependency of two different packages, and the versions here are different. Well, how does Python resolve that? It doesn't do it very well. Let's just say results are going to be undefined at this point. So using virtual environments allows us to separate our projects so that we minimize the chance of a collision like this. We don't eliminate it completely, but we do make it a lot more rare. The other thing that virtual environments enable us to do is it enables us, for example, to do pip freeze and redirect the output to a requirements.txt file and then create reproducible environments. So then we can check in our requirements.txt file, and anyone who has access to the repository can then create a virtual environment based on that file and then install just what they need to run our project, which is really, really a handy thing to do. So virtual environments do two things. They help us reduce package conflicts by not installing everything into the global environment, and they allow us to create reproducible environments, and that means we can install only what we need for a given project. Finally, I said I'd leave you with some other tips for using virtual environments. One thing, if you're using Git, that's important to remember is to add a line with venv and a / at the end to git ignore. If you're using Git, you really don't want to be including the contents of your virtual environment. Again, you can use pip freeze to export your requirements, and you can check that in instead. But you don't want to have the whole binary Python and everything else that's underneath the venv directory checked into your repository. The second tip is to remember that the virtual environment works in the terminal where you activated it. So if you activate a virtual environment and then open up a new terminal, well, guess what? It won't be active there. So you'll need to you need to activate it according to the command that you use on either Mac or Linux or on Windows. Finally, you will have to learn how to use virtual environments in your IDE project. You'll have to make sure you're pointing to it correctly. And I don't want to show you every IDE that's out there, but I do want to take a minute to show you a really cool new feature that just got really fixed or added to VS Code and the Python extension of VS Code. So let's take a look at that now. So behind the scenes, we took a minute to create this demo.py file, and all it does is it imports NumPy and then it uses it to print the numbers from 1 to 10. So not a huge, real sophisticated program. But if you look at this in Visual Studio Code, you can see that it can't resolve NumPy, and it's complaining that we don't have a valid interpreter selected. Now we can go ahead and select one here and go look for our virtual environment. But what I want to show you is something even cooler than that. I'm going to get out of here and I'm going to quit Visual Studio Code. And this is the feature that they recently added to Visual Studio Code. If we come back here and we activate the virtual environment, there it is. Now our virtual environment's active. So this program should run from the command prompt, right? Sure enough, we get the first 10 numbers printed out, 1 through 10. Now if we restart code from this command prompt, you'll notice that we no longer get the warning down here, and we no longer see that NumPy is highlighted. So what happens if we run it from within Visual Studio Code at this point? If we run it, we see a fair amount of output down here, but the important thing is we also see the output of the program, right? So Visual Studio Code now fully supports virtual environments to the extent that if it started from a directory that has one active, it will honor that and try to do the right thing, which I think is really cool because I use Visual Studio Code from the command line all the time. Well, thanks for joining us. I will add some additional links in the description that you can learn more about this and more about Python packages in general. And as always, if you like this channel, it's about Python, so go ahead and like it and subscribe to it. We appreciate it. Thanks very much.